Good afternoon, Alvin ISD geometry students. Today we're going to be talking about sample space. At the very top of the notes, if you notice, we have a couple of words with their definitions. So first, we have an experiment, which is a situation that involves chance, which leads to results which we can call outcomes. Outcomes are actually the result of a single performance or a trial of an experiment, and an event is one or more outcome of an experiment. So it moves us to the next two words we have. So sample space is actually the set of all possible outcomes of an experiment. And a tree diagram is a way to represent the sample space. A tree diagram is actually one of three different ways that we can use to represent a sample space. We can use a tree diagram, a table, or a list. So if we look down at example 1, we want to represent our sample space for this following event. We have a coin that is tossed and then a number cube that is rolled. So this coin being tossed, this is event 1. And then a number being rolled, and a number cube is just our standard 6-sided die. This will be event number 2. So we want to represent the sample space for these experiments by making an organized list, table, and tree diagram. All right, so now if you notice, I actually filled out the tree diagram, the list, and the table for us, but we're going to talk about how they work. So first, our tree diagram, we start with the central dot, which then goes to our first event. Now for our first event, we can flip a heads or a tails. So if I flip a heads first, and then now we look at event number 2, I can flip a heads and then roll a 1, which would give me heads then a 1. I can flip a heads and then roll a 2. I can roll a 3, a 4, a 5, or a 6. Now I still have these same possibilities for my number cube had I flipped a tails on my coin. So I could have gotten a tails with a 1, or a tails with a 2, or a tails with a 3, 4, 5, and 6. So if you notice, we can count the total number of possible outcomes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, which gave us our 12 total outcomes. We then move over to how we can represent it as a list. And again, this is just listing out all of the possible options using commas. So we have heads 1, heads 2, heads 3, heads 4, heads 5, and heads 6. And then all of the same numerical options had we flipped a tails instead. So tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. The third way that we can represent our sample space is in a table. And if you notice, this kind of looks almost like a multiplication table. So over on the left-hand side in our vertical column, we have heads and tails. That's our options for our first event. And in the horizontal row right here, we have all of the options for our second event or rolling our dice. So we have 1, 2, 3, 4, 5, and 6. Now inside of here, all of this area right here, that's our actual sample space. Our sample space would be heads and 1s, heads and 2, heads and 3, etc. for all of the different options. And again, if you look, you still have your 12 total outcomes. Okay, so now we're going to move on to the second example. So I'm going to remove this paper. Now our example 2 is multi-stage tree diagrams. And what this word multi-stage means, it means more than 2 experiments. If we had only had 2 experiments, like the previous example with our coin and our number cube, we would call that a 2-stage experiment because it had 2 stages or 2 experiments. So we're going to take a look at example 2 with Yoki. So we have Yoki, and she can choose a portable hardware with either 4 or 8 terabytes. So this is our first stage. Our first stage is going to be terabytes, and I can get 4 or 8. And then she can choose it in black, teal, sage, or red. So color will be our next one. And I'm going to abbreviate because it's long. So we have black, teal, sage, and red. She can get a case, so she can get a case or she can't. So we have case or no case. So that's our third stage. And then she can get enhanced data transfer rates, or she can't. So that's our fourth stage. So we have data transfer or no data transfer. And we want to make a tree diagram to represent the situation. So we're going to make some room because this is going to take a lot of space. So we'll start with the dot on the far left-hand side to indicate this is the start of our sample space. And we'll actually branch off into the first event, which was terabytes. And I could have had 4 terabytes, or I could have had 8. Now, had I chosen the 4 terabytes, then I need to look at color. I could have had black, teal, sage, or red. So this will break up into black, teal, sage, or red. Well, had I gotten the 8 terabytes, I still have those same options. So this branches into black, teal, sage, or red again. Notice how it looks exactly the same as the top, just now branching off of the 4 terabytes or the 8. So now let's say I have 4 terabytes and it's black. Well, I can still get a case or I can get no case. Same thing for teal, case or no case. Doesn't change just because the color changes, so we still have the case or no case option. And the same for red, we have case or no case. So I now have 1, 2, 3 stages, but I have 4 total. So now we have the data transfer or the no data transfer. So if I have 4 terabytes, it's black, and it has a case, I can still get data transfer or no data transfer. The same if it was black with no case, data transfer or no data transfer. And this will continue off of each branch for not only the top option, but also the option if we had gotten 8 terabytes instead. So I'm going to pause this for a moment and complete my tree diagram so that you can take a look at it when I'm done. All right, now that my tree diagram is complete, we're going to talk about how to read it. So you're actually going to follow the lines almost like a color by number. So this first, if I follow the line, this represents a phone with 4 terabytes, or excuse me, a hard drive with 4 terabytes that is black, has a case that also has a data transfer. Had I branched this way instead, that would represent 4 terabytes, which a black color, with a case but with no data transfer. So just like our previous example, all of these options represent the entire sample space. So if I went here, right here, next to the no data transfer, and I followed it backwards, this represents 8 terabytes in black with no case and no data transfer. So if we wanted to know our total sample space, I would just count all of these lines. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we had 32 total outcomes.